Hi students, and today we will talk about the mirrors formula. As you can see in the screen here, the mirrors formula has been stated as 1 by f is equal to 1 by v plus 1 by u, wherein f is the focal length and v is the image distance and u is the object distance. Now you have to remember one thing, that there are couple of conventions, especially the sign conventions, which we will be talking about, and we will adhere to these conventions to make sure that whatever value we put it in this formula should be we get the right answer. Now let me start with a few things, but before that I just wanted to reiterate that f again that f pertains to focal length, right? V is the image distance from the pole, and u is the object distance from the pole. Okay, now first thing, as my point number one says, that all the distances are measured from pole. Okay, and second point is distances measured in the direction of incident ray are taken as positive and opposite to incident ray negative. So if you if you study or take a note of various books, you will get a sort of a confusing feeling that, like, where the positive direction and where is negative, where is positive and where is negative. So the best way to work it out is always consider the distance measured in the direction of incident ray taken as positive. That means if a ray is coming from south to north, then south to north direction is to be considered as positive. Okay, now let's say if a ray is coming from north to south, then it is opposite to incident ray. So if positive that side, negative is then north to south. Even if you have a slight confusion now, should be okay, because as we go forward and we do more and more numericals, things would be very much clarified. Third point is all height above principal axis are positive and those below are negative. As you see here, this is a mirror, right? And anything above this is positive, anything under this is negative, right? So whatever you have learned earlier, like we have to follow the coordinate system, signs and all, whatever you have studied, just leave it or park it aside for a while doing these questions, and just go with whatever I'm suggesting you here. So this is basically the mirror formula. Okay, so now we are proceeding a bit more, and we will go to the derivations of from where exactly 1 by f is equal to 1 by v plus 1 by u came, which is the mirror formula we have been using. And we will start with the concave mirror. Now in the concave mirror, the first and foremost you should remember that mirrors should be very small in aperture whenever we are talking. So for this derivation, for this formula to be true, the aperture of the mirror should be very, very small, right? Okay, so that's a point to the note, and that is a prerequisite which needs to be followed. Now let's quickly do one thing. Let's quickly draw a mirror. Okay, and we see that in this concave mirror we have a ray of light coming from here. As you see, now it's coming here, and then it is getting reflected here back. Okay, now we know that this is the normal, and the normal always passes through the center of curvature. Okay, now this, as I said, is the incident ray. Point to note that the angle between the incident ray and this normal of the curvature is theta. So angle of reflection would also be the same. So it will be reflected back here, and this angle would be theta. Okay, now That is one ray, and for formation of image, as you know, we need to have at least two images. Okay, object is here, Now let's see the second image. So the second image would come straight, the second image. Let's assume in this, just for this derivation, this angle is alpha and this angle is beta, right? Okay. The other assumption was this is theta, and this angle is theta as well, right? Why? Because angle of incident is equal to angle of reflection. Okay. Now, the center is, it is at a distance of r from the pole. Okay. And this is the object. So the distance from object to the pole is u. Okay. Now image is formed here. So the distance of image, distance of the image from the pole is v. Okay. Now the first construction in this, setup, what I'm doing is I'm drawing a perpendicular from here to here. Okay. So when I say from here to the principal axis. Okay. Now remember one thing, that the first assumption which we have taken here is that, this mirror has a very small aperture. Okay. Remember, very small aperture means this mirror is basically more or less straight. Now, if it is a straight, then P dash and P are actually very, very, very close to each other. Okay. Now, that is number one. Number two, remember, if I take the triangle OMC, okay, let me show you here O, M and C, this triangle. Now in this triangle, and we have studied earlier in the junior classes, that exterior angle is equal to the sum of interior angles, right? So that means gamma, this is equal to alpha plus theta, and that's what I've written here. Very good. Now we are going ahead and we are talking of the triangle ICM. Again I repeat, I, C and M. And the same thing is the exterior angle should be equal to the sum of interior angles. This is theta, this is gamma. So I can say beta is equal to gamma plus theta. And that's what I've written. I have written these two equations here and then I've just subtracted it off. Let's see what comes. But before, that we have to understand it's a normal mathematics, and let me go a bit down. Now, as you see here, if I subtract these two equations, you get gamma minus beta is equal to alpha minus gamma. Taking this side, we'll get 2 gamma is equal to alpha plus beta. Okay, very good. Now, remember, as per the property of, of the trigonometrical ratio tan, that if alpha, beta and gamma are very small, then we can say tan alpha is approximately equal to alpha, tan beta is equal to approximately equal to equal to beta, and tan gamma is equal to approximately equal to gamma. Okay. Let me go back, and just check out a few more things. Now, if I talk about this triangle, tan alpha is nothing but H and this. What is this? This is U. H by U. Now, what you have to remember is, we have to take, because this direction is opposite to the direction of incident ray, and incident ray direction is this, and incident ray direction is always taken as positive. So if I talk about, from here to here, it will be negative. Okay, so I'm taking 10 alpha is equal to h by minus u. Similarly, 10 beta here, 10 of beta is equal to h by minus v. Okay, right, and 10 gamma is equal to h by minus r. Okay, let me go back. Okay, now we already proved this, we already discussed this, that alpha, beta, gamma will be very small. So let's re-put in the values. So if you put in the values here in this, put the value of gamma, put the value of alpha and beta, so basically gamma is nothing but equal to 10 gamma, alpha is nothing but 10 alpha, and beta is nothing 10 beta. So if I substitute these values which you see here, I will get this equation. Finally, in this I can cancel h and I can cancel minus, so I will get this equation finally, which is 1 r by 2 is equal to 1 u plus 1 v. But we know focal distance is nothing but f is equal to r by 2. If I substitute it here, I will get this equation, and that's what we were looking for. Now this was done from concave lens, or concave mirror. Okay, now let's go ahead and let's do the same thing using the convex mirror. The concept would remain exactly the same. Okay, let's go ahead. Now if I talk about the convex mirror, we have to prove this, and let's draw the ray diagram of this convex mirror. Now if I draw the convex mirror ray diagram, I will see that this angle, the ray will come from here and it will get deflected, right? This is one ray, and as I said in the earlier lecture, for drawing the image we need at least two rays. Okay, so the first ray is this, second ray travels from center of curvature to and in principal axis, or across throughout the principal axis. Now this ray would hit the pole here and will be sent back. If the deflected ray I extended backwards, and this ray which gets reflected from here, if I extend it backwards, they will tend to meet somewhere here at this location. Let's say this is I, and let's draw a perpendicular from here to here. Okay, very good. Now let's say the height of this is h. Okay, now I'm drawing these two triangles. One is M, I and C. If you see here, M, I, C. This is M, I, C. This triangle, I've drawn it here. This angle is theta. Remember, if this is the angle of incident is theta, so angle of reflection will also be theta. This angle and this would be vertically opposite angle, which can be proved by basic geometry, because these are the two straight lines. Okay, so this is theta equal to theta. Okay, this angle is beta. Okay, let's assume this as beta, this angle. Okay, so theta, beta, and let's assume this as alpha. Okay, and finally this one, let's take it as gamma. So now in this triangle I can put all the values and then I can write it this way. Similarly, if I take MOC, the bigger triangle, MOC, I'm drawing it here. So if I draw it, so I can write it, gamma is this is alpha, and this angle is theta. This. Now very simple, same theorem, exterior angle is equal to interior opposite angle. So theta is equal to alpha plus gamma, and here beta is equal to theta plus gamma. That is what I've written. Also we can say tan alpha is equal to h by minus u. Now one thing you have to note, that again I've taken it minus u because this is opposite to it. It is opposite to the direction of incident ray. Okay, now tan beta, this angle is equal to h by v. This is h and v is this distance. Now this distance v is in the direction of incident ray, and hence I have taken it as positive. Finally, tan gamma is equal to h by r. So let me take tan gamma is nothing by h, and what is r? R is this, and this is in direction of the incident ray, right? So I've taken it positive. Okay, now if I just substitute it by simultaneous equations, I will get this 2 gamma is equal to beta minus alpha. Now one more thing, alpha beta gamma will be very small, so tan alpha is approximately equal to alpha, and tan beta is equal to beta, and tan gamma is equal to gamma. If I substitute the values here and manipulate it a bit, like I can cancel h, I can cancel what, minus here, minus and minus will become plus. So I will get this equation, 1 by r by 2 is equal to 1 plus 1 by u. But r by 2, as we know, is nothing but the focal length, as I've written it here. Let me show it to you. Yeah, it's written it here. And 1 by f is equal to 1 by v plus 1 by u. And that is what we were looking for. So hence, for convex, for concave, we have the same mirror formula, which we'll be using with sign everywhere. I also narrated you the mirror formula's derivation. I also walked you through with, like, the sign conventions, what all rules we have to follow, and I think we are good to proceed further to the numericals of this. In the next exercise, we will do a few good examples which will give a very good a very good expertise on solving all related numericals. Okay, so I'm just taking a small pause. I'll come back and we will discuss a few more questions related to it. Till then, thank you very much.